right, welcome back to the second part of 4.5. I would pause the video, try this problem out, look at your notes from yesterday and see if you can do it, and then come on back. All right, now that you've tried it, there was two methods in this problem that you could have tried. It had a fraction equals a fraction, so you could have chosen to do cross multiplication, or we could get common denominators. I like to go with common denominators every time because it always works. So let's try that out. Our first fraction had a 4 in it, and our second fraction had an x minus 4. So I needed to add in what I didn't have. So this one needed the x minus 4 on top and bottom, as always. And this one just needed a 4, which is kind of nice. Okay, so let's see. On the bottom, I'm not going to multiply out. I'm going to keep the bottoms the same, which is what we were hoping for. But I am going to multiply the tops out. Now, on that first fraction, be careful when you multiply this out. Do it with me if you need help. So let's look. We had an x times an x. So I'm going to write it up here, x squared. X times 3 would give us 3x. Negative 4 times x would give us negative 4x. And negative 4 times 3, negative 12. So I can put some of that together in the middle. 3x minus 4x can go together. So that gives us an x squared minus a 1x minus a 12. Fabulous. And then let's also multiply out the top of the second fraction. 11 times 4, just giving us 44. Awesome. So now I have that. I have my common denominators. I don't care about the bottom of my fraction anymore. It can go away, leaving us with x squared minus 1x minus 12 equals of 44. So when you do have an x squared and an x in your problem, you're going to go to solving by factoring, meaning we need to set this equal to 0. So to do so, I'm going to move that 44 over. So I'm going to subtract 44 on both sides. So that is an x squared minus a 1x minus negative 12 minus 44 is a negative 56. And now we have that equal to 0, which is what we were shooting for. Because now we can factor. So what two numbers multiply to be negative 56, add to be negative 1? If you need to list out your multiples, that's always helpful. Numbers that multiply to be 56. I just figured out in my brain that it would be an x minus 7 and an x plus 6. Those would multiply to be negative 56 and add to be negative 1. So now that I have that, I can set each equal to 0 to give me my final solutions. This one would give me a positive 7. And this one, would give me, if I solve, a negative 6. So I have two solutions on this one. Now let's also make sure we check our domain as always. See what was on the bottom of those fractions. So there was a 4 on all the bottoms. Now if I do 4 equals 0, it really doesn't tell me what x couldn't equal. There's no x in there. And if I set x minus 4 equal to 0, it tells me x cannot equal positive 4, which we have the answers of 7 and negative 6. So we are okay. Let's try some more problems. Flip your page and let's look at the next one. All right, same process. Now this one is very nice. We already have common denominators, so we don't even need to find that. So let's just dump the bottom of our fractions and focus on the top. So by doing so, we're left with x squared equals 9. We can just solve. Now to get rid of a squared, I can just square root both sides. I don't need to do any solving by factoring. Now this is a very, very big thing that a lot of you, I'm sure, have forgotten, but I'm going to remind you because I'm that nice. Whenever you take the square root on both sides of that equals, you have to add plus or minus. And when I do the square root of 9, I get 3. So I really have the answer of positive 3 and negative 3. But let's check our domain here. The bottom of these fractions was x plus 3, meaning x cannot equal negative 3. Looking at the solutions, we just found this answer is not possible. So even though when we solved it was part of the answer, one of those was not possible. Or in Algebra 2, we call that an extraneous solution. When we solve and we get it as a solution, but it is not possible due to the domain, we call it extraneous. So you can just, when you're doing that, you can just cross that one out if it happened to be part of your domain. All right, let's go to the next problem and see how we do. All right, looking at this one, we are going to start off by finding common denominators. The very last fraction is not factored. So let's figure out what parts did that one have. So it was a 15, multiply to be 15, add to be negative 8. Well, if I factor that, it would be x minus 5 and x minus 3, which is making sense because if we look at our other two fractions, this one has one of the parts, this one has one of the parts, and this one has x minus 5 and x minus 3. So let's do this. The first fraction doesn't have the x minus 3. So we are going to multiply, x minus 3 to the top and bottom of that. The middle fraction doesn't have the x minus 5. So I'm going to multiply that one by x minus 5. And that last fraction already has both. So I don't need to do anything to that last one. Okay, let's see what we get when I do this. I'm going to leave the bottoms the same. I'm not going to multiply the bottoms. I am going to multiply the tops. 1 times this is just going to be an x minus 3. Second fraction, I'm going to leave it the same on the bottom. And I'm going to multiply out the top. X times x is x squared. X times negative 5 is negative 5x. And then my third fraction just stayed the same. So now that I have common denominators, I can just focus on the top. So let's focus on the top of the fractions. So we have x minus 3 plus an x squared minus 5x equals 2. So this is kind of a jumbled mess, but let's make some sense of it. And I'm going to set this equal to 0. So we have that x squared. I'm going to subtract 2 on both sides. Now, if I do that, it's probably going to go with this minus 3 right here. And I'm going to put this in a standard form. So when I go to factor, it's nice and ready to factor. So I put that x squared in the front. We do have some like terms. X minus 5x is going to be a negative 4x. And then negative 3 minus 2 is going to leave me with a negative 5. So by putting it in order from biggest exponent to smallest exponent, I can focus on factoring now. So I'm looking for two numbers that multiply to be negative 5. Add to be negative 4. That that would be an x minus 5 and an x plus 1. So now that I have that, I'm going to take both chunks, set them equal to 0 to find my solution. So x minus 5 is going to give me an answer of positive 5. And x plus 1 is going to give me an answer of negative 1. Now, let's make sure we don't have an answer that's part of the domain. So if we're looking at the bottom of our fractions, let's look over here. X minus 3 would tell me x cannot equal positive 3. We're okay. That wasn't one of our answers. And x minus 5 tells me x cannot equal positive 5. Now that tells me we have an extraneous solution. So my only answer was negative 1. Positive 5 was crossed out. It is no longer a solution because of the domain. All right, let's do another one. Let's find those common denominators to start off. So I have an x plus 2 in the first one, an x minus 2 in the second one, but the last one is not really factored. Now, if you look at it, x squared minus 4 is kind of the same as saying x squared plus 0x minus 4. So we want two numbers that multiply to be negative 4, add to be 0. Well, that's nice. That would be x plus 2 and x minus 2, which, looking at our other two denominators, makes a lot of sense. So in the first one, it had the x plus 2. It doesn't have the x minus 2. So let's multiply this one by x minus 2 on top and bottom. The middle one has the x minus 2. It doesn't have the x plus 2, so we're going to add that in on top and bottom. And the last one already has x plus 2 and x minus 2, so we do not need to do anything to the last one. So let's multiply out our tops and leave our bottoms the same. So the first one has an x minus 2 and an x plus 2 now. And if I multiply that out, it's just x minus 2. Excuse me, my x looked a little crazy. And then we're going to keep the bottom the same of the second one. And if I multiply that by 1, x plus 2. Cool, cool. And then our last one stayed exactly the same. So now that I have x minus 2 and x plus 2 on the bottom of all those fractions, I can just focus on the tops. So I have x minus 2 plus x plus 2 equals 4. Oh, this looks great. This is super nice because on this side of the equals, negative 2 plus 2, those cancel. And we also can put these x's together. An x plus an x would be 2x equals 4. Wow, this is really nice. Let's divide by that 2 on both sides, giving me my answer of positive 2. All right, now let's check our domains just in case. You never know. You always want to check that domain. We had an x minus 2 on the bottom of that, telling me x cannot equal positive 2. Uh-oh. That was our answer. And it was also telling us x could not equal negative 2. So this isn't even, our one answer isn't even possible due to our domain. So in this one, even though we got an answer, it wasn't possible. So our answer is no solution. All right, if you want to pause this video right now, there's one more problem. Try it out on your own, see how you do, and then check back in on the video and see if you did it right. All right, now that you did it, let's check it out, see how you did. Let's look for common denominators. So the first thing you should have done was look at that third fraction. It needed to be factored to start off. So multiply to be negative 6, add to be a positive 1. So that would have been an x plus 3 and an x minus 2. Which, looking at our other two fractions, makes a lot of sense that that was our factors. So the first one has the x plus 3. It needs the x minus 2. So I'm going to add or multiply that out on top and bottom on that one. My middle fraction has the x minus 2. It does not have the x plus 3. So I'm going to multiply that one by x plus 3 on top and bottom. And then my third fraction didn't need anything. It already had both. Okay, so let's do this. Let's see what happens. Bottoms, do not multiply them out. Oops, it was an x minus 2. Leave them exactly the same. I am going to multiply out the top. Now I'm going to do a little writing on that first one because there's a lot to multiply on this first one. So we have an x times an x, so x squared. X times 4 is 4x. Negative 2 times x, negative 2x. And negative 2 times 4 is a positive 8. Oh, negative 8, excuse me. All right, so now when I'm going to go put it down on my fraction below, I can put those like terms together. That's why I wrote it up at the top to make sure I had it all simplified. So x squared plus 2x minus 8. All right, my second fraction, again, I'm going to keep the bottoms exactly the same. And I'm going to multiply out the top. So 2 times x is a 2x. 2 times 3 is 6. And then my third fraction completely stayed the same. All right, now that I have that, I'm going to ignore the bottoms now that they're all the same, and I'm going to focus on the tops. So we have x squared plus 2x minus 8 plus 2x plus 6 equals a 5x plus 10. Whoa, that's a lot of stuff. So since we have x squareds, we have x's, I'm going to set this equal to 0. So I'm going to subtract 5x to both sides. And I'm going to subtract 10 to both sides. And I'm going to put all this stuff together. So there's a lot happening in this problem. So x squared was just all by its lonesome. We had lots of x's that could go together though. 2x plus 2x is 4x. And a minus 5x would leave us with a negative 1x. Then we had lots of numbers also that could go together. So negative 8 plus 6 would be negative 2. Minus 10 would be a negative 12. So lots of things, they all went together. So now that we have this, it's looking like we can solve by factoring. So we need two numbers that multiply to be negative 12, add to be negative 1. So that would be a negative 4 and a positive 3. Now if I took those, I set them equal to 0. The first one, x minus 4, would tell me x equals positive 4. Second one would tell me x equals negative 3. Now before I box this in, I'm going to check my extraneous solutions, my domain, see if anything doesn't work out. So looking at my bottoms, this one would tell me x could not equal positive 2. We're okay on that one. And this one tells me x cannot equal negative 3. Uh-oh, that was one of our answers. So I'm going to cross that out. And my only answer is positive 4. All right, go try that 4.5 worksheet number 2. And let me know if you have any questions as always.